Fun fact, did you know that we've visited every planet in our solar system? Not counting Earth, there are 7 other planets orbiting the Sun. With spacecraft, we've studied each one. These spacecraft send back pictures and information, or data, that helps us to learn more about the planets. But did you know that there are millions of other objects in our solar system that we haven't explored yet? Many of these objects are called asteroids. Asteroids are small, rocky objects in the solar system. Some of them are only as tall as a person, while others are as big as a state. Many of them can be found in the main asteroid belt between Mars and Jupiter. But there is one out of the millions that is special. Its name is 16 Psyche. Scientists think that Psyche was the center of a planet that started to form during the creation of our solar system. So why isn't it a planet now? One idea, or hypothesis, is that Psyche's surface was ripped off through violent collisions, exposing the core. Because Psyche may be the leftover core of a planet, we hope to learn more about Earth's core by exploring this new kind of world. That's why NASA, Arizona State University, or ASU, and Maxar, formerly known as SSL, are working together to send a spacecraft to this asteroid. The goal of the NASA Psyche mission is to test scientists' ideas about how the asteroid formed, what it looks like now, and what it is made of. So how will the spacecraft do all of this? Engineers and scientists are going to design and build tools called instruments to put on the spacecraft. These instruments can collect the data needed to check our hypotheses or ideas about the asteroid. Engineers and scientists create these instruments by following steps that help them to address problems by creating different designs and using the best one. To understand what this process is like, let's find out what the 6 common steps are, though keep in mind that there are many different ways to go through these steps. Step 1 is to ask. Before we can find a solution to a problem, we have to ask what problem we're trying to solve. If we are trying to build a device, we have to know what it needs to do first. We can't design anything until we know what we will use it for. Step 2 is to imagine or brainstorm. After we know what we are trying to achieve, we can try to come up with as many solutions to the problem as we can. This usually means brainstorming several designs. This could also mean using old ideas that we can apply to this new problem or situation. Step 3 is to plan or design. Once we have several options, we can choose what we think is the best solution. Now it's time to actually design it. For example, in this step, we might make diagrams or drawings of all the parts, how they fit together, what they're made of, and so on. Step 4 is to create. After the final design is finished, we can make it. We take the best design we made in Step 3 and follow it to build our solution to the problem. Step 5 is to test. The process is not done after we have finished making our device. We have to test it carefully to make sure it really works. It's important to test the device in conditions that are as close as possible to the conditions it has been designed for. Otherwise, we won't know for sure if our solution has really worked. Real engineers and scientists who are trying to create things to use in space need to try to recreate the conditions of space as closely as possible here on Earth. Testing in space-like conditions is important because conditions in space are much more extreme compared to the conditions on Earth. Step 6 is to adjust. If the tests all go well, then we are done. But if there are any problems, we have to use what we learned from the tests to figure out what is not working. Then we have to come up with ways to change the design to fix the problems. After we have come up with these solutions to these new problems, we can adjust the design, make the device again if necessary, and test it again until we get it right. That's the engineering process. There are many different ways to go through this process. Each step can lead to any of the other steps, depending on what is needed to find problems and create solutions. And when we reach the end, the process can start all over. In the next video, we will see how the engineering process can be applied to make an instrument for the NASA Psyche mission.